Okay, so let's start the previous round. We ended at the combustion of alkenes. Today we're gonna look at a very unique reaction for alkenes. Okay, it's very specialized to alkenes as well. Okay, so um, let's start from this particular one. So we are currently at page 20. Okay, so let's jump straight into it. Okay, let's jump straight into it. Okay, so we know that alkanes, they undergo substitution reaction where the molecules, where the atoms sort of like did a swap. Okay, so substitution reaction is like a swap of atoms between molecules. Huh? For alkenes, now they undergo addition reaction. So the word addition reaction means obviously to add it in. Okay, is to add it in. So if I add things together, I will have at the end one product. So in terms of definition for addition reaction, okay, it is actually a reaction in which two reactants combine to actually form one single product. So it's kind of interesting where it's just like I got a blank space, then after that I add the thing in kind of concept. Okay, this reaction also tells you that lets you understand that because alkenes are unsaturated, that's why they can undergo addition reaction. Okay, so alkenes are unsaturated, that's why they can undergo addition reaction. So when we say they are unsaturated, it means that they actually contains this C double bond C. Okay, C double bond C. So far, okay? Thumbs up if you're okay. Okay, good. Okay, so how exactly to give a general equation to represent addition reaction? So key idea here is alkenes that undergo addition reactions is because they contain the C double bond C. The functional group is the one that actually undergoes that particular reaction. So actually, in a sense, whenever you see alkenes, right, you want to know what reaction they undergo, you just focus on the functional group and look and just evolve from there. Okay, so in this case here, for alkenes, I have a C double bond C. This tells you it's alkene, right, because of the C double bond C. I have an X and a Y that I'm going to add regarding, I don't care what X, what is X, what is Y, but in this case, it's just one of them is an X, one of Y. It could be chlorine and hydrogen, whatever thing. Hydrogen, whatever. So I don't care what the X and the Y is because this is just to show you exactly what addition reaction is. So what's going to happen here? Okay, I'm just going to use some colors to show you. Use blue. So what happens is that in this addition reaction, one of the double bond is broken. The double bond between the X and the Y is broken. The X will come here. The Y will come here. Okay? So I say again, double bond will break. One of the bond in the double bond will break. The bond between the X and the Y will break. Then one of the X will add across one of the carbon. One of the Y will add across the other carbon. And at the end, I'm going to get this. Okay, so whenever you have addition reaction, the X and the Y will always add across two different carbons. I want to write down here, X and Y will always add itself across two different carbons. Okay, so it will never be the same carbon one, it will always be two different carbons. Can? Any questions so far? Thumbs up if okay. Alright, good. Okay, so let's carry on. Now, so there'll be four addition reactions that you need to take note of. First is the addition of hydrogen. Spelling like that today. Sorry, let me write again. First one is addition of hydrogen. So this reaction is called hydrogenation or hydrogenation. Okay, why we call it hydrogenation? It's actually adding of HH. So why am I drawing this HH out? Is just to show you how is it related to your X and the Y. So in this case here, this is the X, this is the Y lah. So you can imagine it. Okay. Next one is the addition of bromine. So this is called bromination. Okay, bromination very commonly tested, so just take note of it. Bromination is addition of bromine. Bromine is Br, Br. Okay. Now the next one is the one that's interesting. It is addition of steam. This is known as hydration because steam is water, right? So it's the hydration. It's like adding water to your alkene molecule. So in this case here, if you remember water is H2O, right? Where exactly is the X and the Y? So think of one side is H, the other side is actually OH. So think of this as the Y, think of this as the X. Can? Now, to be more precise, okay, let me erase this. To be more precise, I will draw it like that. Sorry, wrongly. H, OH. So see this as X, see this as Y, and see this as the bond between the X and the Y. Okay, later on, I'll show you some examples in terms of why I want to draw the water in such a way and why am I trying to make that relation with X and the Y. It helps a lot when you are trying to do the reaction and draw it accordingly. Okay? Now, and the last one is addition polymerization. So we're going to cover this quite a fair bit. In addition polymerization, we're going to cover this concept, these few terms. You're going to learn this thing called monomer. You're going to learn this thing called repeating unit. And you're going to pick up this thing called structural formula, or you're going to be sometimes just called the formula of the polymer. Okay, so these three things are different but related. So I will, using addition polymerization, I'll add in, I'll explain the idea of monomer, repeating unit, and structural formula of the polymer. Okay, more in details lah. Okay, so we're gonna go into details now for each of these hydrogenation, bromination, steam, addition, hydration, and also addition polymerization. I think today we can only maybe complete the first three. I think so lah. We see how it goes. Okay. Okay, so let's continue. Okay, so we're gonna go into now the various reactions. You can see here, there's quite a lot to cover itself. Okay, so you can see from here, this is actually your 1, 2, 3 is hydrogenation. Oops, yeah, let me save. Hydrogenation. 4 and 5, this is actually your can. Okay, this one is bromination. And the last two is actually your hydration. So in this worksheet, we're going to cover these three main reactions. Okay. Now, I just need to take note. Okay, whenever you do organic chemistry, as I mentioned in alkanes, the conditions are like the kind of like requirements for the reaction to occur. Okay, requirements for the reaction to occur. So in terms of these conditions wise, normally you just a recap, you'll always write it, and I got my reactants here. Then I'll write it, in this case here, it'll be something like 200 degrees Celsius, and then a nickel catalyst. Okay, so it'll be written on the reaction arrow itself. So that's how you normally write the conditions down. Why is it a star? Is because in general now, we don't expect you all to memorize the conditions really in the new syllabus. Okay, I say again, you're not expected to memorize the conditions in the new syllabus. Okay? Okay, let's start. So let's carry on now. So let's go on to the first reaction, which is called hydrogenation. So hydrogenation is, as mentioned, or you from the name, you know that it's about adding hydrogen to the alkene. This one is also known as your addition reaction. Okay? So what are the conditions here? As I mentioned, don't memorize, but just take note of it. We will just follow the same thing there. So we'll just take it as 200 degrees Celsius. Sometimes you will see as 150 in some of the papers. Okay, with nickel as catalyst. Let me spell it out. nickel as catalyst. Okay, so let's do part B together. Okay, so first one, Arya, can you please tell me the formula for ethene? I tell you, this is alkene. The general formula first. Arya, help me. What's the general formula for alkene? CN what? Arya.
Can you hear me?
Yeah, I can hear you now.
Wait, general formula or what?
Alkene. So CN what? H.
Oh, CnH2n plus 2.
That's for alkane. Alkene?
Oh, then just 2n, no plus 2.
2N. Okay, no plus 2. Okay, good. Next one, Akid. Hi, Akid. Don't purposely don't talk. I cannot hear you.
Hello.
Okay, so what is the formula for ethene? Okay, C2, H what?
H4.
H4. Okay, C2H4. So I know I'm doing C2H4. Next one, Austin. Hello, Austin. Can you hear me?
Yes.
Okay, how to draw ethene? Describe. I draw. You just describe. What would you do in her first step first?
Ethene. So C, carbon double bond.
Okay.
Then for each of the C's, you draw hydrogen diagonally.
Okay, so this is the part where I want you to take note. Whenever you are doing addition reaction, okay, so thanks, Austin. So whenever you're doing addition reaction, can I have you all to do this? Instead of drawing the bonds diagonally, right? Can you always put the hydrogen at the top and the sides whenever you are doing hydrogen? Leave the bottom empty. Can? So leave the bottom empty. Is it okay? Any questions? Okay, thumbs up. Austin, stop thumbs down. Okay, so just take note, always whenever you do addition reaction, draw it in such a way that you have a double bond in the middle, leave the bottom part empty. So I'm just going to highlight one my bottom part. This part here, leave it empty. Okay, so don't draw. Why? I will show you later on. Okay, so leave the bottom part empty. So you move the hydrogen to the top and to the sides, or draw the thing out such that the top and the sides are filled up, leave the bottom part empty. So okay. After that, I'm going to add hydrogen. So H and H over here. Then I'm going to write the condition. In this case, it will be 200 degrees Celsius. Nickel as catalyst. Now, based on our previous part where we did the general equation, right? Can you see here? Okay, I mentioned that one of the H is X, one of the H is Y. Kieran. Okay, Kieran, help me, So you should be Gladwin, help me. Can you unmute yourself? Can talk. No, Gladwin cannot talk. Okay, come, Gladwin, Kieran, come help me. Kieran can unmute. Hello.
Yeah.
Okay, good. So I'm going to add the hydrogen across the double bond. How do you think the molecule will look now? How many products do you think I should have? After adding the hydrogen, how many products do you think I should have? I got two reactants, right? Reactant 1, reactant 2 over here, right? Right?
2.
How many product will I have?
2. Wait,
Go
1.
back, 1. Okay, so we have 1 product. Okay, so that's good. First thing, 1 product. Okay, next one, Kaden. Hi, Kaden. Can you hear me? Can talk? Hi.
Uh-huh.
Okay, so I want you to imagine this hydrogen as X, this hydrogen as Y. I'm going to draw the molecule out like that. Can you tell me when I draw like that, what was missing What was the difference between A and B? What's the difference?
The double bond.
The double bond. So whenever you do addition reaction, the double bond will
Disappear.
you don't use the term disappear, use the term break. Can?
Oh,
Right? The double
okay.
the double bond will break and my hydrogens will be added in. Now, will both hydrogen add to the same carbon or add to different carbons? Which one?
Different.
Different carbons. So in the end, the H will come here, H will come here. So this is the final product. Arya, now come back to you. This guy here is called ethene. Can you tell me what's the name of this guy over here? What's the product?
Like I'm not sure.
You just look at the whole thing. Anyone want to help him?
Oh yeah, can you just give like the formula?
No, I don't want formula. I want the name.
Oh.
Okay, first thing first. How many carbon does it have?
Ethane.
Ethane. Okay, good. Ethane. So this is ethane. Why is it ethane? Hassan, help me. Why is it called ethane? Don't it on your video, on your mic.
My bad. Yeah, so it's alkane.
How do you know it's alkane?
Right, it's the alkane bond.
No. Alkane has no what?
No double
It's just
bond.
two carbon.
Okay, alkane has no double bond. Actually, in effect, if you look at when you go back to homologous series, right, they say alkane has no functional group.
Yeah.
Everything is made out of a CH bond or a CC single bond. Make sense?
And then
So-
got two carbons.
So 2 carbon plus also it has no functional group. Make sense?
Yeah.
So be able to relate to this. So you realize that when you hydrogenate alkene, so I say now when you hydrogenate alkene, hydrogenation of alkene will produce what? Somebody help me. Austin. So Akid.
Wait, do you call me?
I call Akid first. Akid.
Yes.
yeah.
Hydrogenation of alkene will produce what?
Okay.
Alkane, good. Can? So I hope you're able to see from this equation, you will get this general idea that whenever you hydrogenate alkenes, you actually get alkanes. Can? Okay, thumbs up if okay. Okay, very good. Okay, next. Now we're gonna go on to the idea of polysaturated and polyunsaturated. So the last time we mentioned, when we say unsaturated means it contains C double bond C. Okay, means it has a carbon double bond. If we now say that it is polyunsaturated, Austin, can you tell me what does the word poly means? Please don't tell me it's a tertiary education, okay? What does the term poly means?
Is it polymer?
No, not polymer. What's the word poly means? Mono di. Mono means what?
One,
Di means
two.
2. Poly normally refers to more than 3. So more than 3 normally means that there is a lot lah. Can?
Yeah.
So
Okay.
poly refers to actually many. Okay, so I just need you to take note of this idea. Poly actually refers to like many, okay? Now, so when I ask you to define polyunsaturated, okay, it means that the polyunsaturated actually means the compound contains hydrocarbon chains with 2. Okay, so minimally, when you use the word poly, poly minimally need to be 2. 2 or more carbon-carbon double bonds. Can? Okay, so the key idea here is must be 2 or more. So minimally must be 2. So you can use the idea of polyunsaturated if you see 2 or more carbon-carbon double bond. Okay? So vegetable oils are considered polyunsaturated. Okay, vegetable oils are normally considered polyunsaturated. Okay, so we're going to look at the idea of oil versus fats. Now, some of you say, sure, I know lah, oil is generally liquid, right? Fats are generally solid, right? So why? Actually, all of them are considered lipids. Lipids are, I mean, most of you are bio students, most. Okay, so you realize oil and fats generally they are lipids. But what is the difference between them in terms of chemistry? Okay, so I'm just going to write it down here. Fats contain mainly saturated, okay, saturated hydrocarbons. So the key idea here is saturated hydrocarbons and are solids at room temperature. So I'm going to put RT for room temperature. Room temperature for the first time. Just going to write here, room temperature. Okay. Now, oil contain what do they contain? Can anyone help me? After Austin, Gavin never replied. Kieran, your turn again, huh? So Kieran, can you help me? If fats contain mainly saturated hydrocarbons and are solid at room temperature, what do you think oil will be? Based on that train of thought. Oil contain what?
Saturated.
Unsaturated, okay, unsaturated hydrocarbons. And then what else? And what?
Liquids at room temperature.
Okay, so good. So it's really to draw that contrast between fats and oil. Okay, fats and oil. Now, so oil is a liquid, is generally unsaturated. Fats are mainly saturated and they are solids. So if I think about it, why is this included here? Now you look at C, you look at D. Then now you look at E. You realize C and D is here to help you to look at E itself. So after Kieran, next one will be Kaden. You can talk, right, Kaden?
Yeah.
Okay, so how can oil be converted into solid margarine based on that whole idea of this worksheet that we've been doing, A, B, C, then D? What can I do to convert it?
Put it out.
不知道. Huh?
Put it out.
Okay, what is this whole process that we've been talking about from A all the way to
Hydrogenation.
hydrogenation? So how can it be converted? The process is called? Repeat the same thing again.
Hydrogenation.
So hydrogenation.
Oh.
Okay. Can?
Yeah.
Now, Arya, help me again. What do I add to the vegetable oil for hydrogenation? Add what?
Hydrogen gas.
Okay, I add hydrogen gas, so I add hydrogen. What is the temperature and what is the catalyst that I'm going to use here, Asan?
Like 200 degrees Celsius.
Okay, 200 degrees Celsius and
Nickel as catalyst.
nickel as catalyst. Okay. So when you see Ni is the chemical symbol for nickel, so just think note of that. Can? So this process actually is not too difficult here. So get used to the idea of hydrogenation, where you can turn your alkenes into alkane. It tells you that your oil, generally, they are mainly alkenes. Fats are mainly your alkenes. But take note, it's also not correct to say fats are alkanes because you realize the word is mainly saturated. So it means that they could contain some C double bond C as well for your fats. It's just that mainly they are saturated. So mainly you'll see all CC bond and CH single bond. Okay, Ken? Any questions so far? Thumbs up if okay. Okay, very good, very good. Okay, next one. Okay, so we are done with hydrogenation over here. So take note, you will see the idea of margarine and vegetable oil coming in quite a fair bit. So this is really about the hydrogenation of veggie oil, vegetable oil, to make margarine. So this is actually a real life process that happens. So your margarine is actually, they got the vegetable oil, then they actually hydrogenate it to give you your margarine that you have at home. Okay? So this is an industrial application of hydrogenation. So you are eating alkane when you are, if you can think of it that way, you're eating alkane when you're putting your margarine or your kaya butter toast kind of concept, but they don't use butter, they use margarine. Yeah. So that's actually alkane that you're eating. But many things around us are all alkane. So yeah. Okay, let's go on. Next. Next one, we're gonna now look at this question here. We're gonna now look at bromination. Okay, bromination, can you please put a star here? This is important because it helps to differentiate alkenes and alkanes. Alkane looks so ugly. Yeah. Alkenes and alkanes experimentally. So that means in real life, you can differentiate between an alkene and alkane by doing bromination. Now, why is it so? In order for you to differentiate them experimentally, there must be a difference in observation. So I must observe some sort of difference, otherwise I cannot differentiate them. And bromination helps. Okay, and bromination helps. Now, so let's look at this part here. Do take note, a solution of bromine, this is actually Br2 aqueous, because solution actually means dissolved in water. So a solution of bromine generally means actually bromine aqueous. So I need you to put a star here, take note of this. So whenever we say bromination in your alkenes, okay, it's actually adding Br2 aqueous. Sometimes they might say bromine solution. Sometimes they might say bromine water. Okay, bromine water sounds weird, but yeah, there's sometimes you will have it as bromine water. Okay, now, so the solution of bromine is actually reddish brown, reddish brown. Now, when you have an alkene added to bromine solution, it actually causes it to turn from reddish brown to colorless. You realize there is a change in color. That's why I know experimentally alkenes will actually decolorize or cause my bromine to turn from reddish brown to colorless. This reaction is known as bromination. Now, then, of course, the question is, sure, you tell me you can differentiate. Then what if I add alkane? So if I have alkane added to my bromine solution, what's going to happen is solution remains reddish brown. There is no change in the color. So you realize if I got alkene, it will decolorize my aqueous bromine. If I got alkane, my aqueous bromine will remain reddish brown. It will not change from reddish brown to colorless. So that's why there is a difference. I can observe them. I can differentiate them. Okay, this is important, regularly tested. Please know this. Okay, so first thing first, what's the condition for bromination? If you look at this whole reaction here, okay, look at this whole reaction here, you realize that, your arrow here got nothing. There's no no condition, is it? Yeah, there's, when you write arrow without any extra stuff, right? Generally, the condition means that it will react at your regular room temperature and pressure. So the condition is actually sort of no specific condition, which is just in general at room temperature and pressure. Okay, so at just your normal room temperature, you just add the thing, it will react already. Nothing extra special thing that you need to add in or heat it up or add a catalyst, don't have. You just add the two things together and voila, the reaction will occur already. Okay, so that is for your brominations condition. Okay, that's for your brominations condition. Okay, next one. So write a balanced chemical equation with the full structural formula for the addition of bromine to ethene. So once again, just now the last person I asked is what? Akil or Hassan? Who? Can't remember what I asked. Never mind. Austin. Austin. Hello? Austin.
Yeah. Yes.
How to draw ethene again?
18.
I want to do a balanced chemical equation with full structural formula. How would you draw the ethene here?
Carbon-carbon single bond.
Carbon-carbon single bond, then
And then with 3H connecting to each carbon.
Cia.
Oh. Wait, so
How-
there's only one carbon, right?
I want ethene. Then how?
But are you asking me draw
Oh,
18?
yeah,
Isn't
draw
this
it.
18?
No, you draw single bond, then wrong. Yeah.
Yeah.
So how to draw ethene? What must
Yeah.
I have?
18 you need double bond.
So what must I have now? What am I missing here?
Double bond.
C. Okay, then after that,
Hydrogen. Is that
hydrogen. So how would you draw a hydrogen? I go up, down, left, right, or diagonal. Which one would you draw?
up and to up the
Up?
side?
And the side. Because I'm looking at the addition reaction, that's why I'll purposely draw my hydrogens to the top and the side. Leave the bottom empty. So far, okay? Okay, thank you, Austin. Okay, next one I'm gonna add bromine. What's the formula for bromine? Kieran, help me. Formula for bromine.
BR2.
Br2. But if I want to draw the full structural formula, can I just write Br2 like that? So I'm going to draw the 2Br and the covalent bond in between. How many covalent bond will I have? Kaden,
Yes.
how many bonds will I have between the two bromine? 1, 2, 3. I give you 3 options.
Group. I don't know.
Bromine is in group 17. The valency is 1.
One bond.
Okay, single bond. Okay, so if you got periodic table, you can always refer back to it. So there's single bond here. So if I let it undergo addition reaction, Arya, help me now. How many product would you have after undergoing addition reaction?
One.
One product. Okay, how do you think the product will look? Can you describe it for me?
Like colorless.
No, don't. I mean, draw. I want you to draw it out, but then of course describe. I mean, you can't draw here, right? How would you draw
The
it?
formula, the structure formula.
Yeah.
It'll be like
It'll be like,
I'm not sure.
okay, I help you.
Yeah.
So I must still have my edge at the top and the side. Otherwise, I won't draw at the top and side. So what's the difference between A and B over here? What's the difference? Let's go back to the same question again.
There's no double bond.
So the double bond breaks, right?
Yeah.
After the double bond break, then what's going to happen here?
There's gonna be another bond.
Where the bond
Or
will come
like
from?
below the C with BR, both C's.
Okay, so the bromine will be added across the different carbons. Can?
Can.
Okay, so this is, okay, so I'm going to tell you the name of this fella. You don't need to know the name, but I tell you, this is called 1, 2, sorry, line here, dibromo ethane. Right? This is called 1,2-dibromoethane. Okay, so the key idea of 1, 2 tells you that the bromine is added to the two different carbons. So I want to re-emphasize that after you do addition reaction, the two atoms are added across both different carbons. Okay? Now, part C. Hassan, help me. This one I mentioned just now, right? What do you think will be the answer for this? This will be typically worth at least about 3 marks in the exam, or 2 to 3 marks.
Like
Sorry?
when you add alkene, right, to a bromine solution,
What's the reaction called first? What would you add?
alkene to bromine solution.
Okay, in this case here, my first line I'll add bromine solution to both of them. Okay?
And then you notice that the alkene, the one that the alkene was added, the solution turns colorless.
Okay. Always must have a before and after. So the bromine solution turns from
Reddish brown to colorless.
turns from reddish brown to colorless.
And then for the alkene, the solution remains reddish brown.
Okay, good. So reddish brown to colorless. So this is for alkene. For alkane, the bromine solution remains reddish brown. Okay? So you can see here why I'll say typically worth about 3 marks, because 1 mark for saying adding bromine solution. Then the other one is about the observation for each of them. This can also be worth 2 marks because can be just 1 mark here, 1 mark here. Okay, so that can be also how the marks will be split. So it really depends on what's the demand of the particular question. Ken? Any questions so far? Thumbs up if okay. Okay, only 1 thumbs up. The rest come react for me. Thumbs up. Yes. Make me feel like a celebrity. Thumbs up for me. Okay, sorry, I'm just being lame. Okay, let's carry on. So take note. I just want to highlight again, bromine solution, add bromine solution. Sometimes they can also have the word aqueous bromine, which means the same thing. Or sometimes they can use the term bromine water. So just take note, all this generally means the same thing. Okay, don't need to like go so hard up here, got difference on aqueous bromine solution, bromine water. They're all the same thing in general. Okay, your syllabus take it as all the same thing. Okay. Last one ready that we're going to go into for the addition reaction. So we are done with bromination. Bromination, very short, very simple, but they like to always test. The last one, number 3 here, is your hydration. Okay. Hydration is the addition of Akid.
H2O.
H2O. So hydration is the addition of water. Add water. Okay, so what's the condition for hydration? So this one here, I'll write down for you. It's a star here because I don't expect you to memorize the whole thing. Okay, so this is 300 degrees Celsius. Next one, 60 atm. And then phosphoric acid as a catalyst. Okay, but it will be good if you can remember the condition, because sometimes you'll see the reactions stating this condition. And sorry, this one must put phosphoric 5 acid. When they write down this condition, automatically you know, Archer, I know this one is hydration. Okay, so knowing the condition actually helps you in terms of identifying the reactions. Okay, so write down the chemical equation for this one. I won't bore you with the ethene and everything again. So I'm just going to draw it out for you. Okay, so this is my ethene. Next, I'm going to add my water. So water, as I mentioned, I'm going to draw it out like that. Okay, based on what I mentioned to you. Okay, I want you to see this as X. I want you to see this as Y. Okay? Now, I just want to rent around. Hey, who's turn now? Okay, I call you, right?
Yeah.
Okay, next one, Austin. Aha. Austin, come help me. My double bond broken already. Okay, I got carbon A, I got carbon B over here. What is gonna go to carbon A? What's at the bottom of carbon A? What's at the bottom of carbon B?
This is an is it OH?
A is what?
What do you mean?
What is here? What is here? So below carbon A, what would you draw?
H.
H. Then below carbon B,
OH.
OH. Can you see how the addition is being done? Why I purposely highlight the blue and the yellow is to show you that this bond will be broken. Then the left side will be added to one of the carbon. The right side will be added to the other carbon. Can? So far okay? Thumbs up if okay? Thumbs up. Okay, good. So this addition reaction actually is not tough. Okay. You generally, once you get a pattern of how it's being added, life won't be too difficult. It's always added across both different carbon. Now, anybody has any question at this point in time regarding this addition reaction? Don't have, huh? Okay, let's carry on. Now, this one here, let me help you a bit. Let me help you a bit. So I want to hydrate propene. I want to hydrate propene. Sorry. Let me go back to here first. This is an ethene molecule. Ethene. After hydrating, what is the functional group, Kiran, that you see here? After ethene is being hydrated, what is the functional group of this particular molecule? What's the product? The functional group. Hi, Kiran.
Is that the alcohol thing?
Okay, so this your right hand side, the product actually now becomes an alcohol because it has an alcohol functional group, right? Correct? What's the alcohol functional group? Kiran, come continue.
OH.
OH. So because of this OH, you know that it is an alcohol. This is known as a hydroxyl group, okay, which is the functional group for your alcohol. So what would be the name of this fella over here? So this is a 2-carbon alcohol. Kaden, 2-carbon alcohol. Do you know what's the name? 2-carbon. The name must start with what? Meth, F, prop, but which one? Do you know?
Ethanol.
Ethanol. Okay, so this F, then after that, because alcohol, there is ethanol. Can? So this is an ethanol. So you realize hydration turns your alkene. If alkene undergo hydration, it actually becomes an alcohol. Okay, so you can see how the reactions for alkenes, what happens to them. Now, okay, so back to part C. I'm going to undergo hydration of propene. So I'm going to draw propene out. Propene is a 3-carbon alkene. So 3-carbon, I'll draw double bond on the back part over here. Then I'll draw H, 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 H. Now I'm going to condense this thing down. I'm going to condense this part over here. So I'm going to condense it so that now it looks like this. Can you all see how I make the thing become more compact? Any questions for this part here where I compact the molecule? Thumbs up if okay. Okay. Yeah, so can ready. So let's carry on. Now, so this hydration of propene. So I'm gonna add H. I got carbon A, carbon B over here. Okay, so I just put one of the carbon across the one as carbon A, the other carbon as carbon B. So there's actually two possible products from this particular hydration. So Arya, help me. What is the two possible products that I can get? Give me one of them first. I'm gonna just short circuit this by drawing it out first. Okay, so I draw this part here first. Arya, can you help me? What is the first possible product? What to
Like,
fill? What to fill up at the bottom?
you put H,
H at where?
like the first C.
First,
Middle C, middle C.
middle C. Then after that,
And then like the third C also.
H or OH? OH, down here OH, can?
Okay.
Because it's adding water, so it's H and then OH, right?
Yeah.
Okay. Now, this guy here, can you see the OH belongs to the carbon at one of the extreme side, right? This is actually known as your proper propan 1-ol, because the OH is on the first carbon. Right? This is actually a propan 1-ol, where the OH actually joins to the first carbon. The third carbon, you realize if you rotate, it becomes the first carbon now. So actually this is propan 1-ol. Now, I'm going to draw the same thing again. I'm just going to draw the same thing again. Okay. Next one, can I have Asan help me? What is a second possible product?
You put the OH, the second C.
Second C.
Yeah.
Then the
And the
third,
third one is just H.
what do you think is this fella called?
Open to all.
Yep, so this is propan 2-ol. Okay, so the whole naming thing that I asked you all to undergo and get a sense of it, right, is really to help you to understand this, and isomerism is really to help you understand this whole idea of forming different products just because my functional group changes to different carbon itself. Okay, so I just need you all to take note that when you have asymmetrical reactant, which is like HOH, can you see this asymmetrical? One side is H, one side is OH, right? It is possible for you to get different products out. So you need to draw and then explore the different permutations. Can? Any questions? So far okay? If all okay, thumbs up. Okay. If all is good, today I will stop here. I won't continue already because I have reached the end of your hydration area. So what we have done is we have done hydrogenation. We have done bromination. We have done hydration. Okay? So get used to these three different reactions of alkenes. You realize that when we say alkane is unreactive, you realize, only one substitution reaction. Then when we say now alkene is not unreactive, means it's reactive, right? You realize, this whole addition reaction got so many different type of reactions happening. Yes, okay. So get a sense of these reactions. I just want you to focus on where the reaction occurs. So for alkenes, the reaction occurs at the C double bond C. Okay, so addition occurs at the C double bond C. So your focus every single time when you see alkene, you want to do addition reaction, focus on the C double bond C. Okay? So, yep, that's all from me. I'm gonna end this recording now.